Hi everyone, my name is Shekinah Nicolas from College of Arts and Sciences Education, BS Biology, major in Ecology. And in this video, I am going to show you how to solve the three operations of modulo n. So what are those three operations? The addition, the subtraction, and the multiplication. So why do we study arithmetic modulo n? And why is it important? How is it important in our daily activities? Arithmetic modulo n is basically an arithmetic of remainders. So it is one way of determining the remainder of a division. And it also helps us to determine a leap year and the day of a birthday without looking to the calendar. And it also helps us to validate a book's ISBNs by computing manually, and it also helps us determine the time. So let's start.
First things first, we need to identify what is an integer since we will be using this term later in our video. So by definition, an integer is a whole number that can be positive, negative, or 0. So examples are 0, 1, 2, 3, 4, and so on. It can also be negative 1, negative 2, negative 3, and so on, as long as it's a whole number. So what are those numbers that considered non-integers? Those are fractional numbers such as 3/4, 1/2, 1/3, or any fractional numbers are not considered integers. Decimals like 0.24 or 2.34 are examples of non-integers or any numbers that are in decimal form. Let's start with the addition modulo n. We have two items here. Let's start with the first item. Just add these two numbers. 27 plus 34 is equal to 61. Just copy the mod 8 and then divide the 61 by 8. 61 by 8 is equal to 7.625, but we will only get the whole number, so let's eradicate the decimal numbers. 7 times 8 is equal to 56. So we will just simply subtract 56 to 61. So 61 minus 56 is equal to 5. We have another example here. So 39 plus 84 is equal to 123 mod 7. Then just simply divide 123 by 7. So the answer is 17.571, and again we only need the 17. So 17 times 7 is equal to 119, and again let's subtract 119 to 123. So 123 minus 119 is equal to 4. Let's proceed to the next operation, which is the multiplication, and we have another two items here. Let's start. So 18 times 7, since it is a multiplication, we will multiply the two numbers is equal to 486 mod 10, and then 486 divided by 10 is equal to 48.6, and the rule is erase the decimal places, and then 48 times 10 is equal to 480. So 480 subtract to 486 486 minus 480 is equal to 6. Another example. Same process. 21 times 32, multiply these two numbers is equal to 672 mod 13, and 672 divide by 13 is equal to 51.69. Remove the two decimal places times 13 is equal to 663. 663 subtract to 672 is equal to 9. The last operation of modulo n is subtraction. We have another two examples. So 43 minus 18 is equal to 25 mod 7. 25 divide by 7 is equal to 3. Since it's a whole number, 3 times 7 is equal to 21. 21 subtract to 25 is equal to 4. In this case, our subtrahend is bigger than our minuend, so we will get a negative answer. But take note that a negative answer is still an integer as long as it's a whole number. 27 minus 36 is equal to negative 9. Since the result is negative, we must find the value of x so that negative 9 is congruent to x mod 6. The next step is to divide the negative 9 minus x over 6. By definition, it is equivalent to negative 9 plus x over 6. It must be an integer. To find the value of x, try to substitute the whole number values of x less than 6. So it might be 5, 4, 3, 2, 1. In this case, we find that when x is equal to 3, we will substitute the value of x, negative 9 plus 3 over 6 is equal to negative 12 over 12. And when we divide negative 12 by 12 is equal to negative 1. Note that negative 1 is an integer.
So that's the 3 arithmetic operations of modulo n, and I hope you enjoyed and learned something from my video, and I hope you can use that in the future.